Section 1.7 is all about solving equations graphically and then solving systems of equations. So we've actually solved equations graphically in the previous section of our notes. If you turn back the pages of your notes and you look back at the beginning of section, both section 1.6, the beginning of section 1.6 here, when we solved absolute value of x equals 3, we graphed the absolute value of x in purple and the line y equals 3 in orange, and we found where those two things intersected. So we're going to use that same idea to start off section 1.7. If you're trying to solve an equation algebraically, you can always check your work graphically. So for example, I've got this equation, 2 times the absolute value of x minus 1 plus 3 equals 7. I want to solve that algebraically, but then I can also check my work graphically. So this is a really good skill to be able to show your thinking in two different ways. So if I wanted to solve it algebraically, I would start by subtracting 3 and getting 2 times the absolute value of minus 1 equals 4. Then I would divide by 2 and get the absolute value of x minus 1 equals 2. Now that the absolute value is by itself, I can write my two separate equations. X minus 1 equals positive 2, and x minus 1 equals negative 2. I'll add 1 all the way around, and I will get x equals 3, and x equals negative 1. So let's see if this holds true when we graph both sides of this equation. So let's start by graphing this absolute value equation in orange. I've got 2 times the absolute value of x minus 1 plus 3. When I look at this absolute value equation, just as a reminder, this number out in front is my vertical stretch, compression, or reflection. This number on the inside is my horizontal shift, and the number on the outside is my vertical shift. So I always start with the h and k, my horizontal and vertical shift. This tells me to go to the right 1 and up 3 for my vertex. So I'm going to start right 1, up 3, and put a point there. The 2 tells me that instead of going from the vertex over 1, up 1, this time I'm going to go over 1 and up 2 spaces. It stretches it by a factor of 2. So on either side of this vertex, I go over 1, up 2, over 1, up 2. Same thing on the other side, over 1, up 2, over 1, and up 2. So there's my nice absolute value function. And I'm also going to graph the other side of the equation, this 7, maybe in a separate color. That's just a horizontal line straight through the y value of 7. So I'll graph my horizontal line. And so far I'm in luck because that horizontal line does hit my absolute value function. If I look down and see what the x values are, where I hit the absolute value function, I see that my x values are negative 1 and x equals positive 3. Which is what I got when I solved algebraically. So just a way to solve an equation both algebraically and graphically. It's a really good way to check your work and to show two different methods. So let's try the next one. I want to solve this equation graphically first and then check my solutions algebraically. So if I want to graph this one, this 2x minus 1 is just a straight line with a slope of 2 and a y-intercept at negative 1. So we'll start at negative 1, and then my slope is up 2 over 1. It's important to start recognizing when you have an absolute value function and when you have a linear function. I know this is not an absolute value because I don't see those absolute value bars, so I should not see a V shape on my paper at all. Just a straight line. I'll now graph the other side, y equals 5. So just a straight horizontal line through the value, y equals 5. So when I look and see where those two lines intersect, I get the x value of 3. So let's check that algebraically to make sure it works. 2x minus 1 equals 5. Well, I know to solve that equation, I start by adding 1. I get 2x equals 6. Divide by 2, And I do get x equals 3. All right. For the next one, I'm again going to solve this system graphically, and then I'm going to check my solution with a graphing calculator. I can't actually solve this equation algebraically yet because this absolute value section equals a linear section that's not just a number by itself. Because there's an x on this side, I don't really know how to get the x by itself necessarily. So I'll start by graphing my absolute value. Y equals the absolute value of x minus 3. When I look at that, I do not have a stretch or compression. I do not have a vertical shift. I just have a horizontal shift to the right 3. So starting at 0, 0, moving to the right 3, I'm going to put a point. Since I don't have a stretch or compression or reflection, that just means I'm going to go over 1 and up 1 to make the nice V shape for absolute values. And whenever you're trying to find points of intersection, I would recommend making your points go all the way across your page so that you can very clearly see points of intersection and you're not guessing. Okay. For my other equation, I have y equals 3 minus 1/2 x, where this is a linear, there's no absolute value. It sort of looks like mx plus b. The m is just at the end of the equation next to the x, and the b is at the beginning. So I'm going to start up at 3 on the y-axis, and I'm going to go down 1, right 2. Down 1, right 2. Down 1, right 2. And I'm going to keep going. You can also go up 1, left 2. Connect my points. And I see that I intersect 2 different times. I intersect at the x value of 4, and I intersect at the x value of 0. Since we can't solve this algebraically, I'm going to show you how to check your solutions with your graphing calculator. So if you get your calculator out, we're going to start by clearing our calculator. Second plus 7, 1, 2. Again, this just helps because if your calculator still has some of the regression data that we did in our last class, it's going to get rid of all of that data so that you can start fresh. Okay, so now I'm going to go to y equals, and I'm going to type these 2 equations into my y1 and my y2. The first one is y equals the absolute value of x minus 3. When I look at this calculator, I don't see anything that says absolute value. So I hit this math button. Math is a great place to look when you don't know where something lives on your calculator. So if we hit math and use our over arrow to get over to number, we see ABS. That stands for absolute value. So we're going to select that, and now my absolute value bars pop up. And we're going to type in x minus 3. If we scroll down to y2, now I type in my linear equation, 3 minus, to type in 1/2, you type in parentheses, 1 divided by 2, close your parentheses, and then an x. It's always a good practice to put fractions inside parentheses. Okay, so now I'm going to hit graph. If you successfully reset your calculator, you should have a good window already. And luckily, it looks like what I drew on my paper. I just want to make sure that what I actually got for my points of intersection matches here. So to find points of intersection, we hit second trace. Number 5 says intersect. I'm already kind of on my first intersection, so I just hit enter 3 times. 1, 2, 3. And I get that, yes, the intersection there was at 0, 3. X does equal 0. Let's try one more. Second trace. Number 5 for intersect. Now I'm going to move over to my other point of intersection. And again, just hit enter 3 times. 1, 2, 3. And I also get x equals 4. Okay, for the next one, we're just going to keep going. Solve this equation using your graphing calculator. So now I just want to use the graphing calculator. We can draw our window here. So if I go back to my calculator, I'm going to go back to y equals. I'll clear out the previous 2 equations. I'll type the first side of my equal sign into y1 and the second side into y2. So I've got a fraction, 1/2, 1 divided by 2, that I'll put in parentheses. For absolute value, I hit math, go over to number, select number 1, x plus 1. and then minus 5. Now in y2, I'm going to put the other side of the equation, 10 minus 2x. I'll hit graph. There's my absolute value. And there's my line. Here I only see one point of intersection. So, second trace, select number 5, and we're going to move our little blinky dot over to that point of intersection. Hit enter 3 times. And I got that the intersection is 5.8 comma negative 1.6. When I'm solving the equation though, I only want the x value because I'm solving this equation for x, and the x value then is 5.8. Okay. And the last one that we're going to solve using our graphing calculator is actually an inequality. So I'm going to come back to that equal sign, or that inequality in just a little bit, but I'm going to pretend it's an equal sign for now. So again, back to our calculator, you go to y equals, clear out the equations that are already in there, and we have 2 times the absolute value of x with a minus 3 on the outside, and then for my y2, I have 1 minus x. I'll hit graph. Here's my absolute value. There's my straight line. So I do actually want to get a picture of this on my notes. So let me go ahead and draw that real quick. I've got something that kind of looks like this with the absolute value. And then my line is kind of steep, comes through something like that. Okay, it's not the prettiest picture, but it'll help us visualize what we're looking for. Okay, I'm still going to find these points of intersection. There are 2 of them, so using my calculator, second trace, number 5 for intersect, and then I'll find both of them. Enter, enter, enter. So my first x value is negative 4, and my second x value is 1.333. Okay. I'm remembering though that I'm not actually solving for what x equals, I'm solving this inequality. So I know that this first x value was negative 4 and this second x value was 1.333. So when I look at this, I'm looking for when the absolute value function is bigger than the linear function. Another way to think about that is I want when this absolute value function is above that line. So if I look at it that way, I've highlighted the parts of the absolute value function that are above the diagonal line. The parts that I've highlighted as they correspond with the x values are to the left of negative 4 and to the right of 1.33. So any x value that's to the left of negative 4 is going to fall in this highlighted section of the graph, which means that any x value less than negative 4, less than or equal to, will work. Any x value to the right of 1.333 will work. So that means that any x value greater than or equal to 1.333 will also work.